Welcome to TUTS Plus. My name is Jose Mata. This course will help you learn the very basics of programming using the Ruby language. This course is all about the basics. You're not required to know about programming already, so if you're just a beginner in the world of software engineering, then welcome. This course is just for you. If you feel you already know a little bit about programming and Ruby as well, then you're free to skip the entire course and check the other advanced courses we already have in our network. So feel free to jump ahead. This course is all about the basics, as I've mentioned. We're going to go to the very fundamentals of programming constructs. From how to print a statement to the screen, to read some input from the keyboard, and manipulate our programs in order to do our bidding. You're going to learn to do some magic, so stick around. There are absolutely no requirements whatsoever. All you need is a computer with an operating system working, which I assume you already have. If you're watching this video, then you most likely have an operating system, either Windows, Mac OS X, or even Linux. So let's get started right away. Let's jump into the next lesson in order to set up our development environment. I'll see you soon. In order to set up our development environment, we're going to need three things: a utility program that will allow us to run our code, a text editor that will allow us to write our code, and finally, a language that will help us create an application. These are the essential things, and we're going to take care of them step by step. The first application that we'll need is a terminal. A terminal is a little piece of software usually available in each different operating system that will allow us to run a particular set of commands. For our workflow, we are going to write some code using Ruby and a text editor. We're going to save our code in a file, and then we will go to that terminal app and run that file that contains our application, our program. Specifically for Mac OS X, you can either use the standard terminal application or you can use iTerm, which I prefer. I'm going to post a link in the description below so you can download it yourself. Here is the terminal window that I'll be using, and most likely this is what you'll see. Well, not exactly with this color scheme. If you want to, I can share it with you. Check the description. And you will see this funny looking string. It might not be exactly the same thing as you see here, but it will resemble closely something like this. This is a prompt that contains a line waiting for us to type some commands in it. For example, I can type in pwd to check the working directory I'm in. This is the full folder structure that I'm in. I have a projects folder under my user account, and inside I have a Ruby folder and the name of the course to separate the content. So as you can see, this is one of the many different commands that we can type. Most likely you will be under your home directory, something like this. I'm going to type in pwd, and you will be under /users/ and the name of your account. You can navigate to the folder that you wish by using cd and then the folder. I can type projects and then /Ruby and then /learning to code with Ruby. I press the tab key in order to get some auto-completion. When I press enter, I will go to that directory. You should be able to do the same thing. Of course, you would need to create that specific folder structure. You can go, for example, to the Finder and go, for example, here and create a new folder. It would be whatever folder you would prefer. If you want to make things easier, just write the whole set of files that will build throughout the course in your home directory, and then when going back to the terminal, you just need to go to your standard working directory and run the Ruby commands from there. Now that's out of the way, let's talk about the text editor. If you don't know, there are a lot of different text editors out there. My personal preference is Vim. It is a text editor that runs in the terminal itself. but I'm going to give you a better suggestion for beginners to start off really easily. The Atom Editor is a relatively new text editor in the scene. You can use the download button, extract the contents of the zip file, and drag it onto your applications folder. The fun thing about this Atom text editor is that it works for any other platform. In fact, if you check here, other platforms, you will see a bunch of different questions and answers, and at the very beginning of this web page, you will see that builds are available for OS X, Windows 7, Windows 8, Ubuntu Linux, and Red Hat Linux. If you are indeed using Linux, most likely you'll be using this distribution, and so you'll be able to download the specific package once you go to the homepage. Since I'm using macOS X, the button to download the application will be available for me. For Ubuntu, it might be a different button, and the same thing goes for Windows. This is my editor right here. You can see that it kind of looks something like this throughout all platforms. You can see that I have a lessons directory, which I'm going to use to separate the content in between lessons, and also an outline to help me guide you through the entire process of developing software. So you can see here that I already have a terminal window which we will use to run our Ruby code, and on the right side I have the text editor in which I'm going to write my code in. Now the last thing that we need is the actual language. We need Ruby installed in our machine. So how can you do that by yourself? Well, it turns out that on macOS X, the very latest version, it already has a stable version that we need to use. It is Ruby version 2.0.0. The one that I'll be using is Ruby 2.2. I'm using a relatively recent version. It's from last Christmas. So it's pretty recent if you ask me. It should be more than enough to satisfy our learning needs. In the Yosemite version of macOS X, the version should be 2.0.0, which is also good enough. If you're on Windows, then you won't have that pre-installed. Instead, you'll need to download this package available for you to install Ruby on Windows. It's very easy to install things this way. You just click on the download section here, and you pick the very latest version available in here. As you can see, it is Ruby 2.2.1. You just click on that, and it will allow you to download an executable file. Just double click on that and follow the instructions as with any other installer. So it's really easy to get Ruby set up. Once you do that, you will be able to go to your own terminal application. I believe it is called the console. So you just open that and type in ruby-v as I did previously. You can see on the top that I've typed in ruby-v, and the Ruby version that's being used is there. As far as Linux goes, you have this tool right here. This will allow you to install a Ruby version manager. If this sounds too complicated for you, don't worry. It's really easy to set up because if you scroll down a bit, you will see this instruction that you can paste on your terminal window. Should I type this into our command line, you will be able to download our VM and then install a Ruby version by passing in this little snippet right here. I'm going to show you how to do it. So I'm going to select this text. As you can see, I'm going to copy this, and then I can go straight here to the terminal application. I'm sure you have your own under Linux. So you paste that in there. Let me just clear the screen. And also you can type in --Ruby. This will not only install the version manager, not just the application that manages your Rubies. You can also straight away install one Ruby version. So this will most definitely install the latest one. So you should be good to go. Since I already have it, I'm not going to do this. Once you do this, you will be able to run your own Ruby code. We have our terminal, our text editor, and Ruby as well. So we're ready to start doing some code. Let's start by the very basics in the next lesson. Jump right in. So before we jump straight into writing an actual program, I want to explain you a little bit what programming is. You might be wondering whether it's too hard or too easy to write a program, right? Well, that really depends on many different things. Well, first of all, you have to consider the difficulty of the challenge that you want to tackle. It's easy to think that you can do anything with programming, but once you pick up on a challenge, you might actually be really scared. After all, you have to learn a whole way of defining your thought. Programming is both a science and an art. I like to think it that way. Well, of course, it's scientific because you need to resort to science and to technology to achieve a certain goal. Produce a certain program that does something that you expect. That's the whole part of the science. But then there's the artistic side, where you give wings to your imagination and you express yourself through code. It can be either Ruby or any other language, really. The reason there are so many different languages out there is because they fit different purposes. I personally like Ruby for many different things. For one hand, Ruby is really easy to learn. Its syntax is very easy to learn, and you can achieve things really fast without beating yourself too hard. There are other languages that are far too complicated to even mention at this stage in your learning, but that might even be an incentive to you to learn other things so as to expand your knowledge and your possibilities of achieving certain goals and expectations for your career. So I'm going to show you here a little diagram that explains very briefly how a program works. In this specific case for Ruby, we are going to use a text editor to write some Ruby code that goes into a file. The file will effectively be our program. You need to pass that in to the Ruby interpreter so that it runs. If you want to, you can pass in some input into that program, which then gets digested and most likely will produce some output. That is the simplest way that I can show you how a program actually works, the nature of programming. We will do something in these terms throughout most of the course. We will write a Ruby code that expects some input, we are going to process it, and we will return some output back to the screen. It is the simplest form of interaction between a program and a user. So we're going to do that until the very end of the course. I hope you understood what it means to program in its most basic form. We're going to focus our attention on basic algorithm constructs. You will see what these are once we progress through our learning. The first thing to consider is input and output. Jump right into the next lesson to see how you can do that in Ruby. The most common use case that you'll see around in the internet for printing and reading output is through the screen and through the keyboard, respectively. We will use two specific functions available in Ruby for this lesson. One of them will print out some content into the terminal, and the other one will allow us to type in some text with our keyboard and store it somewhere in the program, which we will then spit out to the screen again by using the first function. This is the simplest way to demonstrate how a Ruby program works from the moment we write it to the point we run it. As you can see in our text editor, I am inside the folder that I've mentioned previously under Projects, Ruby, Learning to Code. The same way as in the terminal. You can see that this is the same folder as in the editor. I'm going to jump to the Lessons folder under the first chapter. This one contains a series of files that we'll navigate through in between lessons. So this is the first one that I'm going to select, and as you can see, I already have a comment and an instruction. As I've told you previously, it is all about writing code through a series of different instructions. The first one is a comment. A comment is a line that won't be interpreted by the Ruby command, and so this will just be ignored. The lines that do matter don't have that pound sign before each different line, so this instruction will be run and the previous one will not be interpreted. So let's think about what this actually means. This is the classical Hello World example, and you can see that this instruction, put S, takes a text right after it, what this will do is it will print something back into the screen. The puts command or instruction refers to put string. So we will put a string of text back into the monitor. We can go straight away to the terminal and try to run this code. So I will run the Ruby command and I will pass a file. So we'll navigate to Lessons, then the folder in this chapter, and then the actual file. You can see that this path is relative to the working directory we're in, and then we'll just keep navigating through. At the end of it all, you will see this .rb file, which stands for a basic Ruby file. At the end, you just press enter, and the code will be run in front of your eyes. You have successfully written your first program. Hello World is printed out in the screen because we told the program to do so. Now let's do a different thing. We're going to write some more code, but this time it will read a string from the keyboard and we will spit it back out. What we'll do is we'll create a place in our program that will store whatever text we type in the keyboard. So I'm just going to call it text. Text is going to be the result of typing this instruction, get s. Get s is another instruction that does the exact opposite as this one. If this one prints something out, this one captures something in. We are going to retrieve some content back into the text variable and fix that term, as we'll be using that throughout the entire course and most likely throughout the entire career of yours in software development. So the next thing that we'll need to do is to print that string back out. We are going to type in the put string again, but instead of printing a whole text, we will just print out the contents of that variable like so. That's really all there is to it. That's all we want to do. Let's try and see what this is all about. How should the program behave now that we've added some new code to it? Well, what we need to do is just run the very same instruction again. We type in Ruby and then the path to that Ruby file, and it will interpret each different line one by one from top to bottom. You can see that the Hello World text is being printed out again, and notice how it is hanging. You know, the cursor is right there. It is telling us that we should type something in. Let's say, for example, that I want to type in my name. So I'm just going to do that. Press enter and notice the behavior of our program. So press enter and my name is going to be printed out again back to the screen. Remember, this is the thing that I've typed in and this is the result of printing it out. Those are two different things. This is the most basic form of a program. You print something out or you take something in. The basic form of writing a program is in this way, but we're going to find a lot more different constructs that will allow us to build more complex programs, and also different ways of taking input. Now let's jump right into the next lesson where we'll learn about the various different variables and their types. We have just messed around with strings of text, but there are also other kinds of variable types that we can use. So jump right in. In this lesson, we're going to learn about the different kinds of types available in the Ruby language. Even though we're still talking about Ruby, most of these types that I'm going to show you will most likely be available in other languages, such as Java, or Python, or JavaScript, or even C. Those are some of the different languages available in modern technology, so I'm going to start by creating some different variables. Up until now, we have just messed around with plain text. We have printed out a string of text called Hello World. So if we do that the same way, so I'm just going to type in Hello World. If we use the put statement to print something out and just do something like this, we will get its type. Every single variable has a class. Think of it as a type of data. So I'm going to do this right away, just going to save that, and I'm going to run that specific file. By running this command, you will see that the result we get is string. String is the type that resembles a chain of text. So anytime you see string like this, you will know that you will be handling text based on that. Now let's take a look at other different kinds of variables. I'm going to print out another thing. For example, what about numbers? We also have numbers in the Ruby language, as well as different languages. So for example, I'm going to print out this content. I'm going to print out what type is the number 3. I'm going to save this file, clear the screen of the terminal, and run the command again. The same way as we were doing before, the very same file, no changes whatsoever. I'll press enter, and this time we get the string from before, and then fixed num. The usual term for fixed num in Ruby is called integer, like this. Integer is the name that's usually around most languages, but the Ruby developers decided to make it a fixed num, because it doesn't have any floating point. Speaking of which, I'm going to print out a floating point number as well. Remember pi? 3.14 is also a number, but it's not exactly a fixed num number. If I type in 3.14 and then .class, we will get a different result. So if I press enter now, you will see that 3.14 is a float. A float is a number that has decimal places, just like you see here. .14 is the decimal part of this number, and 3 is the integer part. So you now know 3 different types of variables. Let's check other types. There is one specific scenario that I want to demonstrate, and that is the result of printing true.class. Well, what is this true kind of variable? Is it really that important? Well, of course it is. You will learn later on in the course that this true expression, and whoever talks about true also talks about false, so let me just print that right away. These are what they are called as booleans. They represent a state. So true represents a positive state and false represents a negative state. Whenever we try to evaluate something as being true or false, we will act accordingly. And you will see that later when trying, for example, to learn about control structures such as if and else. Decision making. Whenever some condition is true, we will make a decision based on that. And the return of the condition is either true, like so, or false. So if I save the file now and run the command again, you will see 2 different types. Even though they are basically the same thing, they're not. And that's because of the way that Ruby works. They are still booleans after all. This is the primary concept, if you wish. Both are booleans because they represent a state, either true or false, positive, negative, turned on, turned off. Think of that analogy as you progress through your learning. So true and false are represented like so, and they will allow us to do many different things later on. So true and false are also covered. Let me consider, for example, a list or an array, if you will. Let me also demonstrate the power of arrays. Think of arrays as lists of different variables. I'm going to create an array right away. For example, I want to create an array with true, then false, then the number 3, then my own string. I'm actually going to type in, for example, my name to be simpler. And for now, that's it. This is the array that I want to portray. If I print out the type of this variable, I will get a different result. So let's do that. You will see that below the true and false classes, you will see array, because this is indeed an array. It's a list of different elements. We are going to cover a lot more different variables and types as we progress further, but I want to show you one more special case, and that is the nil type. If I do something like that, let me just print out the content right away, you will see that nil is a nil class type. Again, this is the way that Ruby works. In other languages, nil is just nil. and nothing else really. The nil concept is a little different from false. Sometimes you can evaluate nil and it will return false, for example, when trying to make a decision, but nil is definitely different than false or zero or something like that. Nil represents a void kind of type. Let's say, for example, that you have a program that lists blog posts and each different post has an ID. Consider, for example, that you have 3 posts. The first one has the ID of 1, the other one has the ID of 2, and the last one has the ID of 3. If you try to look up a blog post that has the ID of 4, which doesn't exist really in your records, then a good idea would be to retrieve nil as a result. Nil is a void state, and it tells us that nothing exists. Trying to find a blog post that doesn't exist should return nil to make sense. You know where I'm getting at? So this is a very special kind of type that we'll be using later on if the occasion shows up. For now, we're going to stick with all of these different types. These are the most basic ones and frankly the most common throughout most languages. Oh, there's just one more thing that I want to show you, and this will allow us to distinguish between this one and, for example, the string. I'm going to print out a symbol. This symbol, if I print out the type of this kind of variable, it is going to return symbol. There you go. What is the big difference between introducing a symbol or something like this? I'm going to type in symbol. The main difference between a symbol and a string is the position in memory. And I'm going to demonstrate something that's really nice, and you will enjoy this. I'm going to print out something like this. I'm going to compare the object ID of one string to another different string's object ID. So let's see if I try to make myself clear. In fact, I'm going to go ahead and comment all of these so that we can focus our attention on this very string. I'm also going to do the same thing, but with the actual symbol. So I'm going to do that like so. There you go. As you can see, these are 2 different things. I'm going to print out whether the object ID here is the same as this one, and the same thing for the symbols. So I'm going to clear the screen, run the command, and you will see that the first condition returns false, remember the type, and the other one returns true. So the symbol here is the same one as here. It's the same entity in our program. Whereas in line 11, these are 2 different entities. They have different IDs for each different variable. This is very curious for you to learn because you will appreciate symbols a lot more now that you know this particular characteristic. Strings are always unique in time. So if you create one at a particular point in time and another one that looks exactly the same, they are indeed different. But as for the symbol, they are the very same thing. Okay, so that's about it on variables and types. Throughout the entire course, we'll be messing around with all of these different variables and different types. So stick around as we learn about decision making. Whenever we're trying to develop a program, we will most likely have to deliberate a decision based off a condition. We're going to learn how we can achieve that in Ruby, and most likely it will resemble other languages as well. The constructs are basically the same, they just differ a little bit in syntax. So, decision making is really straightforward. If a particular condition is met, then we are going to do something. Perhaps print out a different statement, execute some command that we want, and we also have the scenario where the condition is not met. And in case that happens, then we might want to do something else. That's all there is to it. Let's start by creating an example. Let's mix some concepts from other lessons so that we consolidate our learning. Let's print out a statement first, so that we can tell the user that he is expected to type some input. So I'm going to type in something like this. and I'm going to provide a sample auxiliary string so that the user knows what he should point out as the content of the gender. I'm going to create that variable, and we will assign this variable using the equal sign via the getS method. So, what exactly are we doing here? We are printing a string into the monitor so that the user knows what to do. It is just a helper text to support our user experience. We're asking the user what letter he should type, either M or F. Then we're going to create a variable called gender, and its value will be the result of the getS command. So I'm going to provide a chomp method here, and don't worry about what that means or how it is constructed. Basically, this operation inside getS will get rid of the enter key. Well, wait a second, what am I really talking about? Well, let me explain you really quick. Let's consider the scenario where we're actually trying to run the program. When we get that phrase, we will be asked to type in some text. And so when we are trying to type in the text in the terminal, let's say, for example, we type in M, and then we press enter, right? Well, it turns out that the getS method also captures the enter key. It is pretty odd, I know, but in order to strip that enter key from the string, we use that chomp operation the same way as you see right there in the text editor. That way we will only keep the letter and not the enter key. Now we can pick up on that variable and evaluate it. So let's pick up on that gender variable, and if it is the letter M, for example, and notice the difference between using one equal sign and two equal signs. Using one equal sign will tell the user that the contents of the right side of the equal sign will be assigned to the variable on the left side. Using two equal signs will compare both ends of the instruction. This is assigning the value of getS to gender, and this one is comparing gender to, in this case, the M string. It can be anything inside. It can be another variable, it can be a number, a true, nil, it doesn't really matter. You decide. In this particular case, we want to know whether the contents of the gender variable is equal to M. If it is, then we're going to print out, for example, it's a boy. And we're going to print out the end instruction at the very end to enclose the if statement. Remember, when trying to evaluate a condition, you will always need to type in if first, and then the end to delineate the whole body of the if instruction. Okay, so we also need to consider whether the hypothesis of being a girl is also covered. Let's do another if condition here. If gender equals F, then we're going to print out it's a girl. There you go, really fluffy, just the way we want it. So if the user has typed the M letter, and we will use that to evaluate against our gender, then we're going to tell our user that it's a boy. And if the gender letter the user has provided us is F, then we're going to tell him it's a girl. So if we save this and go to our terminal on the left side, and we specifically run this file, remember that I'm using the specific file under the respective chain of directories. So let's press enter now, and you will see that the content is being printed out. It's telling us to fill in something. I'm going to press the M letter, and notice that I'm using a big case. Pressing enter, you will see that it's a boy. Now let's do the same thing for the female gender. I'll press big F, enter, and then it's a girl. Now, what about the case where we type in some gibberish? What if I type in the letter X? Well, it just doesn't print anything at all, because it doesn't match either condition. Let's take care of that right away. And we're going to do this with a simple refactoring technique. Notice how we're using two separate if instructions. If we want to, we can merge these two if conditions together by using this kind of notation, else if. So if this condition is met, then we're going to print out this statement. And because the way this is written, it won't even try to evaluate this, because the first condition was met already, so it skips the second part. Nonetheless, if the first instruction fails, then it's going to go to the other instruction. Next, we want to consider the condition where the user has entered a letter other than these two. We use the else condition, and that's it. We put out another string. For example, I don't know that gender, and that's it. One particular and very important thing is that you don't need an else if condition to write an else statement. This is also valid. So I just wanted to clear that out of the water. The most important thing, though, is that you have at least one if statement with the and keyword at the bottom, and then you can mix and match else ifs and elses as long as there is only one else condition. You can have as many different else ifs, but only one else and only one if. So if we save this file, go to our terminal and rerun this code and type in, for example, X, it's going to tell us that it doesn't know that gender. Pretty great. There's also one particular way of doing conditions in Ruby specifically, and that is by using the unless keyword. Let's say, for example, that unless the gender is M, then we're going to print out the content of it's not a boy. I hope you understand where I'm going at with this. So let's consider the example where we just want to say whether it's not a boy. So unless the gender is M, then we can tell for sure that it's not a boy. So I'm going to save this file, go back to the terminal and run it. If I press, for example, F, it is going to say that it's a girl and also that it's not a boy. The fundamental point of using unless is just the plain opposite of if. That's all there is to it. So what operators can we use in the if condition? What can we do to compare other kinds of things? Well, we already know about the double equal sign, which compares one thing to be exactly the other thing, but we can do other kinds of stuff. I'm going to consider another example. So I'm going to comment this whole exercise to provide a different one. Let's make an exercise with numbers. I'm going to provide an if statement, and this is going to be a lot simpler. I'm just going to pick up on a variable, let's say number, and this number will be anything. It can be, let's say, 5. Let's pick on that number and compare it to other variables, other numbers. So if the number, for example, is 5, we already know this one. But there are other operations that we can use. For example, the different than is also available. We can tell something like this. And in this particular scenario, we would say that it's not 1. See where I'm getting at? This is really, really straightforward. It is the exact opposite as you can see here on the double equal sign. Instead of the first equal, you use an exclamation mark. We can also use other operators. For example, if the number is greater than 10, we can print out another kind of statement. So we would say that it's greater than 10. This is one of the operators also available. And we can also append an equal sign here to make sure that it is 10 or greater. So it includes the number 10. This one tells us that it should be greater than 10, not 10 or greater. This one includes the number 10. The same way as you can do with greater than, you can use less than. This will tell us whether it is 10 or less than 10. And you can also omit the equal sign, and it will tell us whether it is lesser than 10. Of course, we should also change this text so it is less than 10. So this would be a good scenario. These are the most common operators available for comparing numbers. Usually, you will like to compare a particular variable to be the same thing as the other, so you should be good to go with these examples. Now let's go ahead and jump to the next lesson to learn about how we can loop through a collection of elements. you will see what the purpose of them will be. So I'll see you soon. Loops are generally very useful in programming. I'm going to consider an example for you that will demonstrate the effective power of using those loops. I'm going to show you 3 examples. Let's take a look at the first one, right here. This example regards the for loop. We have a list variable, which will be an array. Remember those? These are lists of different elements. We're going to loop through all of the items in this list, and we're going to do something about them. Not just to put some text onto the screen, but rather to do some funny little coding. As you can see here, in line 8, I am looping through each different item in the list. This item variable can be anything that you find most useful. I'm just assigning each different item in the list as item. This list variable is important because it should already exist in your program. So we're going to take on this list, loop through all of the different items in it, and then we're going to manipulate this string variable, which is empty. And in line 9, you can see that we are going to add in some new content back into that string. This is an operator that's available in the string type that will allow us to shove some more text into it. So we're going to add item with a blank space. At the end of it all, we're just going to print out a string that has all of those different strings separated by a blank space. That seems about right. Let's take a look at a different example where I demonstrate the power of using a while loop. It is a lot different than this one because this assumes a list and this one does not. So in the while loop, we are going to provide a condition. While the condition that's shoved into the while statement is true, then we'll do something. You can see that n begins at 0, and we're going to verify whether that n number is less than 15. While that's true, we're going to print out that number and increment the value of n. In the first iteration, you will see that n will be 0, but we're going to add 1 to it. So we will constantly be adding one number to n until it reaches the number 15. When it is 15, then the loop will stop and we will move on to the next part of the code. The same thing goes for line 23 and forward. In this case, we're going to use the until keyword, and this will only break if the condition is true. If it is not true, then the code inside will be run. So basically, it is the opposite of using while. We're going to do the same thing. We're going to print out the content of n and increment it. So these will do the very same thing, but in different constructs. Let's go to our terminal and run this file. As you can see, it is number 5. You can see that in the source code if you have it. I'm just going to press enter now, and you will see 3 different things. First of all, there's the text with all of the spaces in between the different words in the list on the right. Then you get the first loop, and this is the one with the while instruction that we've typed in lines 15 and forward. And the last set of numbers comes from lines 24 and forward. In the first loop, we managed to evaluate whether n was less than 15. If it was, then the code inside would be run, which is not the case with the latest instruction. Using the until statement, we will run this code unless the condition is true. I've made it so the result at the end is the same, but it does different things. This is the power of using loops. You can traverse and repeat a particular set of code through many different elements. That way you can traverse through different arrays, different lists of elements, and do something for each one of them. One particular case that you might be familiar with is, for example, a blog. Usually there is a page with a list of all of the blog posts available in that blog. What you want to do with that page is circle through the entire list of blog posts, retrieve the title, and print it back to the page. It uses a loop just like this one in line 8. We will retrieve the list of blog posts somewhere else, and then we're going to use a for statement that will take each different post, retrieve the title, and then print it back out. That's the gist of it. So I hope you understood the power of using loops through many different ways. In the next lesson, we're going to cover something that's really special: functions. At some point in your learning process, by applying the principles I've already taught you, you will come around the necessity of constantly repeating yourself, trying to do some things over and over again, and only if you thought of a way of extracting a particular piece of code that could be called every now and then without repeating yourself. Well, that's what functions are for. Functions in programming aggregate a specific behavior into one single body of code. They have their own signature, and they allow you to call that function over and over again. We're going to do that in this lesson. Let's think of a context really quick. I'm going to print out the following sentence onto the screen. What is your name? This sentence implies that I'm going to ask for a name, so I'm going to do that. I'm going to create a variable called name, which will be the result of getS, and then don't forget that I'm going to use this specific instruction to remove the enter key from the input from the keyboard. This is the only scenario where you'll need to use it. We're also going to provide another instruction saying, what is your age? And we're going to provide an age variable here, which is going to be the same thing, getS.jump. Remember that I'm using this in order to retrieve the age. What I want to do next is just to provide a simple string, for example, some sort of a greeter. Something like, hi, and then a particular name. You have told me you're something age old, so age years old. Here's where it gets tricky. Let me give you a really quick tip. You can see that I've put in here name and also the age right there. There you go. How can you put the name and the age directly onto this string? Well, this is very easy to achieve. Usually in other languages, you would have to separate the string, then add plus, then whatever variable you wanted to put out, and then continue on with that string. With Ruby, there's a particular scenario in which you can interpolate a variable inside of a string. What you can do specifically is provide a £sign with a pair of curly braces, and notice how Atom, the text editor, has already put everything inside. I use the name variable, as you see here on top. So, you can do the same thing for the other variable, so we'll do that. Age inside, and there you go. Let's try and run this code to see if we have any errors. I'm going to go to the terminal and run this specific file. It is the one with 06, so you can see that we have the question being popped out. I'm going to type in my name and my age. If I press enter now, you will see the phrase being built up and printed back to us. Now, about those functions. How can we extract this specific body of code and make it so we can repeat it all over again? Let's say, for example, that we want to ask 3 different people. What can we do? Well, we can use a function to accomplish that. The way you define a function in Ruby in specific is by calling the def keyword and then the name of the function. I'm going to call it, for example, ask for name and age. Okay, there you go. Now, this function will contain the entire body that we've already written before. So I'm just going to indent this really quick. So, as you can see here, we now have our own function. We can save this file and try to run it in the terminal. But unfortunately, it is not going to run itself. It is going to return nothing at all. So, even though we just defined the body of this function, we need to call it. So, we'll just type in ask for name and age. So we need to do this in order to make the function run. So now we can go to the terminal, run the same file, and you will see the question being popped out. So if I type in my name and my age, you will see the final catch. Now, what if we want to do this more than one time? If we didn't have this function defined, so this would be deleted and this as well, we would have to copy this entire load, and that would be counterproductive. It's not exactly the best idea to constantly having to repeat ourselves. So in order to tackle that challenge, all we need to do is create that function and repeat the function name. Usually, functions take arguments, but this one doesn't take any. As you can see, we haven't defined any parameters in here. So if we want to do this twice, we just copy the same method being called. So let's do that. The first one, and then for example from a Bob. So Bob is for example 15 years old, and we get that function being run twice, which is pretty good. Now let's talk a little bit about parameters. As I've told you before, we are not passing anything here. Let's do something a little bit differently. I'm going to create yet another function. It is going to be called print name and age, and all it's going to do is it is going to print out the contents of the name and age. But where are these going to be located? Well, if you guessed it, we're going to put those as arguments in that function. Remember that we still need to call that function from here, so we use print name and age in the body of the other function. You can call functions within functions, so we can go ahead and do that, and we need to pass in the name and age the same way as you will be doing when defining the function. Curiously enough, these parameters are the same as here. They have the same name, but they're not exactly mandatory. The priority is the order in which they are passed. So let's say, for example, that if I pass the age first and the name next, and then saving and running this file again, we would have a different result. So passing in Jose here and then my age, you would see that this is totally bonkers. I'm not called 28 and my age is not Jose. So bottom line, you can change the names between the arguments in the definition and when being called, but the order must be the same, otherwise it will be inconsistent. This is the gist of defining functions. The whole purpose of them is to extract behavior into a single place, and then when we want to call that same behavior either once or more than once, we just ask for the function name. If it takes any arguments, we must define them in the body of the definition, so right aside the function name, and when calling that function, we just pass those in as such. In the previous chapter, we've learned about all of the programming basic constructs, such as decision-making with if and else, traversal and repetition through loops, and also about the different variables and types available in most common languages. In this lesson, we're going to learn about something different. We're going to learn about the object-oriented approach to software development. Programming using objects and classes is really fun, and I'm going to show you their purpose. So up until now, we have used the most basic types, such as whole numbers, numbers with decimal places, strings of text, booleans, and also nil. In this case, we're going to learn how to define our own types, our own classes. That's what they're called. So I'm going to give you a very simple example of how to create a class and use them in a context scenario. I'm going to provide this to-do class. The to-do class is our own. It's not available in the standard Ruby library. It is our own creation. Classes allow us to define our own universe, our own system. So in this particular case, the way we define a class is by typing class first and then the name of the class. And notice how the first letter is uppercase, so the word is capitalized. Then inside the class, we define its set of features and behaviors. For example, here in red, you can see what is called to be instance variables. These variables are unique in the context of a Ruby application in the way that they define a new object based off this class. So whenever we create one to do, it will have a title attribute, a due date, and also a status attribute. These define any new to-do object. As you can tell by the structure of this example, we have two methods, two functions defined inside this class. They are part of each different to-do object that we create of this class, and we can call them as part of the to-do object scope. As you can see here in line 21, we are calling to-do dot and then mark as done. To-do is a new instance of the to-do class. So the class is just the blueprint for new objects to be spawned. Think of it as a production line where we have some sort of a blueprint, a template, based off which we create new instances, new products based off that blueprint. The initialize method is really peculiar. It is the method that is called when calling to-do.new. When we create a new instance of any class, we use the new method, which in turn is going to call the initialize method inside the class definition. As you can see here, we are using a string of text to define the title, and then a new instance of time. So we'll just create a new time object with this date. So December 24th, 2015. This date will represent the due date available in the constructor. The title and due date are arguments to this method, to this function, and they are going to be passed in and assigned to the instance variables respectively. Also, we're going to create a new status instance variable that is not provided as part of the constructor. We're just going to define it as the new symbol. Then in the mark as done function, which takes no arguments, we're going to create another instance variable called finished at, and it's going to be a new instance of time. And notice how I'm not passing any arguments whatsoever. By default in Ruby, when creating a new instance of time, it matches the current time. Then the status instance variable will be switched to done. And that's it. So this is what we'll do in line 21. As you can see, we're going to mark it as done. And then in between operations, we're going to inspect the to-do object. Remember, the capitalized to-do is the class, the blueprint. The small to-do is an instantiation of the blueprint. So this is an object. If we run this file by using Ruby and then the path to that file, you will see the same object but with different properties over time. Let me just expand this a little bit and run it again. You can see that the first line matches the object created without manipulation. So just the basic constructor, which is going to be inspected. You can see the title instance variable there, then the due date set to December 24th, and also the new status. When we mark the task as done and inspect it again, you will see two new things. The status is set to done, and we have a new finished at attribute, which matches March 10th. And notice how it is set to 11 o'clock and everything. This is the time of the recording. Also notice that the object is exactly the same because it has the exact same address in memory. So this is the very same object that we're dealing with. So this is the power of using classes and objects. They allow you to define your own universe with your own set of properties and behaviors. That's all there is to it. Think of classes as Lego pieces. Your imagination is your limit, and depending on the way that you construct your Lego construction, you can achieve different things, different goals. The to-do class is rather easy to understand because it matches something that it's really close to you. We create one to-do with some information on the title and due date, for example. We can mark a status as well. It is set to new by default. And then when we want to mark it as done, representing, for example, the striking through of the to-do in your notebook, you create a new finish that attribute to represent the date you finished it, and then you mark it as done. It's really, really easy. One other thing that I'd like to mention is the fact that we have this instruction right here. AddAReader is a special function available when defining a class that will allow us to expose certain instance variables. For example, if I didn't have this here, we wouldn't be able to access the title or due date or status for that matter. In fact, let's try and do that. I'm just going to comment this thing out and try to print out the contents of the title. So we'll do puts todo.title. If I try to do this and run the code as usual, we will get an error. You can see that we don't have the method called title. All instance variables are private from the outside, so no one can access them the way we just did. If you want to expose a certain variable to the outside, you'll need to use AddAReader and then use a symbol that matches the instance variable. In this particular case, I just want the title. Now I'm going to do a little thing, and that is I'm going to put in the status to the screen. So I want to print both the title and the status. If you guessed right, you will see that the title will be printed out, but the status won't. This is the title. As you can see, everything's okay, but then we have this undefined method error. Status isn't there, and in order to solve that, we will need to add in that AddAReader as part of the list of instance variables that can be exposed. Okay, so let me put this the way it was. There you go. I hope you understood the basics of this topic. You'll be using it throughout your entire software career, should you choose to pursue Ruby as a main language of yours or any object-oriented language for that matter. So be sure to understand it. With that said, let's jump to the next lesson to learn a little bit about modules, how they fit in the Ruby ecosystem, and how you can take advantage of their features. In this lesson, we'll cover the topic of modules. Modules are a little different from classes in the way that they provide different responsibilities. Let me show you. The way you define a module, at least in Ruby, is really simple. All you have to do is type in module and then the name of the module. The same way you would do with classes, you type in a capitalized word. In this case, I'm going to create a greeter module. I think this looks good because I want to implement two distinct functions. In the module, you define functions the same way as you would do with classes. But as I've mentioned before, they serve different responsibilities than classes. So let's define a hello method and also a goodbye method. Both of these will take a name, for example. Let's do that. Now, in the hello module, I want to type in something like hello and then the name, for example. The same way I would do for the goodbye message, we'll put out a string to the screen saying goodbye and then the name. Okay, so in the module that we have here defined, we have two different functions or methods. Methods are a more common way for functions. So if you hear me say methods a lot, then you know that it means a function. These two methods are inside the greeter module, which we can then call. Let's say, for example, that I want to use greeter.hello. So we want to call the basic method inside the module. Will this work? Well, let's try it out. I'm going to go here to the terminal and I'm going to run the very same command we called Ruby with the path to that Ruby file. You will notice that this will prompt an error. You can see that the module doesn't have the hello method. Well, you're asking yourself, well, the method is there. Why shouldn't we be able to call it? Well, The reason for that is we need to type in something like this. We type in the class method like so, here, just before the method name. This will now work. So if I go to the terminal and reload it again, there you go, there's our greeter method. So you can do something like this in order to make the module work as a class, if you think of it that way. But this is not the main purpose of using modules. So what I'm going to do here is I'm going to create a new class. The class will be, for example, a person class, which will have, for example, a name or something like that. Let's do that. I'm going to define a constructor. So the initialize method will take a name, and the name will be stored as an instance variable. Let's finish the function definition, and I'm going to do something very particular. In the class person, you can see that it doesn't have either hello or goodbye, right? Well, one particular functionality of modules in Ruby is that you can include that module into a class. So if you use include greeter, then you can call those methods as part of the person class. For example, I'll create a new person variable, which will be a new person. Let's pass in my name, for example. Now, the person object will be able to call hello to someone else. Because we've added this include statement and passed in that module that we just defined, we will have the whole set of methods in that module inside the person class, or object in this case. So if I save the file, go back to the terminal, and run this command, you will see that it works. Bob is being greeted by us because this person object is being called the hello method, which is inside the greeter module. This is one of the main purposes of using modules. If you want to include a set of methods that can be extended in many different classes, then you can use this strategy. It is really, really cool. Another utility for modules is namespacing. Let me do that for you. I'm going to remove this instruction here, and I'm going to define a module outside of the person class scope. Let's see. Let's suppose we have our own application. Say, for example, the Tuts Plus application. We can define a module as a namespace, and all of the classes that are defined within that module will belong to it. This means that this code will no longer work. And why is that? Because the person class is not in the global scope. It is in the Tuts Plus module scope. Just to let you know, I'm going to run this code, and you will see that person is not initialized. There's no constant, no class with this name. However, if I go here and type in Tuts Plus :person, this will now work because we're referring to the entire chain of hierarchy. Now I'm going to go back to the terminal and run this command again, and it now works. No errors have been thrown. You can still include the module as before, so I'll just do that, include greeter, because greeter is in the main scope, in the global scope, and it's easily referable. If I type in person.helloBob, this will not present any errors. It will work. There you go. These are the two main purposes of using modules, either for including a set of functions or methods to be included into another class, and also for namespacing purposes. This can be really good in order to organize your code a little better. You will find this pretty useful later on. Let's pick up on the previous exercise about modules and classes and think about exceptions. What are those really? Well, let's pick up on the actual person here. I'm going to try and retrieve the name of the person. If you recall from the previous lessons, you will know that this will throw an error. So if I provide the Ruby command with the respective exercise file, there you go, I'm going to see an error. This no method error word that you see here is actually an exception. This is the entire message. undefined method name for this object, tuts plus :person, and the address in memory. You can see the instance variable and everything, but the point is that this is an exception being raised. Exceptions are raised and caught. Let me show you how the normal procedure for capturing an exception works. So I am going to start by providing a begin keyword that will tell Ruby that we are going to try and catch an exception, rescue it. So let's try and print out the person's name. Next, we're going to close the begin block because this is mandatory. Usually, every construct in Ruby begins with a keyword and then the end keyword at the very end. In other languages, you might see the use of curly braces to enclose the behavior that's supposed to be handled. So, the begin block tells the program that we are expecting to rescue a particular exception. If we type in rescue first, with no arguments at all, we are going to run the code that's inside regardless of the exception being raised. The exception must be raised though. So if we try and print out something like, whoops, something went wrong, this should probably work. So if we try to access the name of the person, which you can see that it is not valid because we don't have that add a reader feature in this class, remember that? So if we save this file, go back to the terminal and rerun this piece of code, there you go, there's our oops message. So you can see that the rescue block is indeed capturing our exception, but we really don't know which one it is. How can we do that? Well, we type something into the rescue block. We use some sort of a hash rocket, as you can see there, and then a variable. This variable is the exception that's being rescued. So if we try to interpolate this string and inject that variable, let me do that really quick. There you go. I'm going to print out the contents of this exception into this string of text being put into the screen. So I've saved the file now, and I'm going to run the same command again. We can see our own message, something went wrong, and then you see the exception, undefined method name for this object. So that's great. Now let's try and do something else. Let's retrieve the actual class name for the exception. This is just so you know what kind of object we'll be retrieving from the rescue block. You can see that it is no method error. It turns out that in Ruby, you might want to capture a specific exception, or even multiple exceptions if that's the case. So let's say, for example, that we want to try and rescue no method error. Just that. You add in that specific exception name before the hash rocket. So if we try and save this, it should still work. So let's run that again. It works. Now, if we try to rescue a different kind of exception, for example, argument error, which is another kind of exception, this won't work at all. So if we try and do that, you will see that we get the exception as if we had nothing at all. So the rescue block doesn't consider this no method error and simply lets the exception raise up until the very top level of the program execution. As I've mentioned before, you can rescue more than one kind of exception. So we could provide, for example, any other kind of error, like this, and put out something different. For example, whoops with no message, and here we could replace this as, for example, missing arguments maybe. And this should be more appropriate to resemble this kind of error. So I'm going to save the file now and run this again. Oops is now retrieved, because that's the message that we were expecting for any other kind of exception. This is the standard behavior on capturing exceptions. Of course, you can raise an argument error. Let's force this message to appear on the screen. So before the person name here, or we can actually remove it, I'm going to provide, for example, a raise call and argument error. If I want to, I can pass a message. For example, forcing the exception to be raised. This is actually pretty funny, come to think of it. We are forcing an argument error to be raised so that we can expect this message being there. Let's save the file, go back to the terminal, and run this code again. You will see that missing arguments maybe is the message being provided. You see, you can either rescue the exceptions or you can raise them by yourself. This can be either good or bad. If you are raising an exception, that means that something might have been wrong, and you want to let the user know, whoever's developing an application, that an exception is supposed to be raised and they should take care of it. Otherwise, if you're the one trying to rescue the exceptions, you should provide a rescue block. If you want to provide a variable here and do something about it, just try to capture the error and manipulating to whatever's necessary in your program. That's all there is to it in regards to handling exceptions in a very simple way. You either rescue them or raise them depending on what you should do. In this chapter, we're going to cover 4 main classes available in the Ruby standard library. They are 4 different types of data that we can use in order to write our programs more effectively. We're going to start off with the string class. We've been using it all along from the very beginning of the course. Strings just hold text. That's it. But there are a lot of hidden treasures behind this class. I'm going to demonstrate you how you can use strings more effectively. As you can see, I'm inside the terminal. I've maximized it just to be easier for you to take a look at it. I am inside our project folder. In this line, I'm going to type in the following command, IRB. IRB stands for Interactive Ruby. It's a command line utility provided by the Ruby language that allows us to directly type Ruby code and instantly retrieve the result. Let me press enter and you can see that we have a different kind of prompt. It's a Ruby prompt. Inside this command line utility, we can type in as many different Ruby instructions as we want. We will always get the result after each different line. So if I create a sample string here, I will get that very same string back. Now this is just a very basic string. Nonetheless, it's still an object. If I type in sample string and type in the class method for this object, I will get string. You might not have realized this before, but practically everything in Ruby is a class. Even nil is a class because we've tried this before. Nil.class is an object of the type nil class. This is just to prove a point. Let's continue on with the power of strings. So I'm going to create a variable here. I'm going to store the contents of my name, for example, inside that string. There you go. You can see that the return value is the content of the last instruction. Since we have assigned a string to my string, the content of this variable is printed out. Now, what happens if we want to manipulate this string? What methods do we have available in the string class? I'm going to demonstrate you about 5 or 6 so you can get a quick grasp of what you should expect. You can check the full list of the string class methods in the link that I'm going to provide in the description below. So what can we do with this string? If I type in myString.reverse, for example, this is one of the methods available in the string class. So if I press enter now, you will see a funny looking string with the letters all switched around. The last letter of that string is now first and vice versa. Basically, it turned the string all the way around. This might be useful in some situations. Let's continue on. Let me clear the screen really quick and call a method that's actually pretty peculiar. I like this one a lot. Let's type that string again, myString and then dot downcase. If you guessed it right, what this will do is it will turn all letters downcased. So the big J and big M from my name are now downcased. The same goes for the upcase method. This method turns the letters all the way up, like I'm shouting or something. Let me pick up really quick on the downcase method here. You can see that this returns the string. So if it returns a string, I can chain another method inside. This is really awesome. So we have our string variable. We'll use the downcase method, which in turn returns the string, and then we can call another method on top of it. So if I use, for example, the capitalize method, I will get just the first letter upcased. If I were to use the instruction on the variable itself, it wouldn't really be apparent. It turns out that it will downcase everything already and then turn the big letter back up. Remember that none of these methods will affect the original string. As you can see, it's still intact. The big J and big M are still upcased. So none of these methods are destructive. They don't override the content of that original variable. All of the methods return a new string, a new object. It's the principle of immutability. So let's continue on with some more methods. One method that I like a lot, and I think it might be very useful to you, is the length method. Let me type that in. The length method, if you guessed, retrieves the number of letters in that string. There you go. It includes the spaces in everything. So everything counts. Punctuation also. One other method that I like to show you is the split command. If I type in the split command with no arguments, you can see that it is going to split the string by a space into a list of different strings. So in this particular case, I get my name in an array. But what if I want to split it by another character? Let's say, for example, that you have a list of different things in a string with several different new lines, enter keys. So each different item would be in its own line. You would pass in \n, which represents the enter key, or the new line really, and it would retrieve an array with all of those different items in their own position in a list, in a proper list. In this case, if I do that, I won't get anything. Now, what if I want to split by the letter O, for example? Let's do that. I'm going to split this string by the O letter. Pressing enter here, you will see that all of the O's disappear and I get J, Z, M, and then T. That's pretty funny if you come to think of it. So this is just a demonstration of the power of this method. You can use it to split strings by a common pattern and manipulate each different item its own way. Okay, let's continue on with one final example. Let's pick up on the myString variable. You can see that it's still intact, nothing has been changed. And what if I want to check whether it includes a particular string or not? For example, the include question method, and notice that the method actually includes the question mark. That's all one method. It's a particularity of Ruby and not from other languages. There are methods that also include, for example, the bang method. This is not the case, however, but they're still valid as Ruby methods. They're not syntax errors or anything. So the include method allows us to check whether a particular string is included in our variable. So if I type, for example, Jose, like this, it will return true. If I try to check whether the U letter is included, I will get false. It's not there. This is good for identifying patterns inside strings that might tell you that you need to do something about them. That's actually pretty common. So these are just some of the many different methods available in the string class. Believe me, there are a lot. In fact, let me go straight to our browser and type in, for example, Ruby string. A quick search on Google would point us back to the string class definition in the Ruby documentation. This is the link provided in the description below. If you check the list of methods here, I'm just going to scroll these down for your own pleasure. It's a really big list of methods, and they're all pretty well documented on the main part of the page. Each one gets its own description with some examples, if that's the case. So I hope you've enjoyed this string class. Most of the time you'll be dealing with strings because that's where the data is held. Let's jump into the next lesson for the next type, arrays. This next class has also been approached in the beginning of the course. It is the array class, and it is also going to be a big part of your software development life. Strings and arrays are all there is to it almost. Probably even more than numbers, if I say so myself. So I'm inside the terminal here, and I'm going to type in the same IRB command we used in the previous lesson. We're going to use the interactive Ruby shell to demonstrate some of the array functions that I think you'll find most useful. Let's create a variable first called array. As you know, arrays are defined within a pair of square brackets. Let me type my name, for example, in between different items of this array. So my first name at the beginning, then my last name, and maybe, for example, some numbers. I'll type in something like the Christmas date for this year, or really the Christmas Eve. It really doesn't matter. This is one particular feature about Ruby. A Ruby array can have different types of variables in the array, unlike other systems such as Java or C or C++, in which all items must be of the same kind. In this case, we have strings and numbers, so fixed-sum objects. So in this case, I have two different kinds of data, but that's okay. We can manipulate this array the same way. In this variable, I'm going to demonstrate some functions. The first thing that I should demonstrate is really how to access each different element in the array. And pay close attention as this might bring some confusion. Let's consider our array. It has 5 different items. Now imagine I want to retrieve the first item. How do I do that? Well, you use the myArray variable, and then you use the square bracket notation. For arrays in specific, you use a number. It represents the index or the order in which it is inserted in the array. I'm going to pass the number 0 to retrieve the first item in the list. You might be thinking, well, isn't the number 1 supposed to be the first element? Well, in programming, the number 0 is the first element. It is a zero-index approach that makes this instruction work. The number 0 is always the first one, not 1. In fact, if I want to reach for the second item, I use 1. And so on and so forth. Number 2 will give me 2015, but watch as I, for example, retrieve the 7th element because it's index 6. What do I get? Well, we get nil because there's no item in the 7th position with index 6. You need to be careful about that. Just pay attention when trying to reach out for a particular index. Have the care to check for nils. If there's an item in that specific index, then it will retrieve a value. Otherwise, it will return nil. Okay, now let's try and write a value into the list. I'll use the same variable, but this time let's say that I want to manipulate the first item in the list. I use that position, and then it is going to be equal to something else. If I replace this with Mr. Jose, it's going to be replaced. In fact, if I go ahead and check that array again, there you go. The first item in that list is updated. This is how you read and write values into an array. You'll most likely be using this most of the time. With that said, let's move on to some particular functions that I think you'll find useful. Allow me to begin with the first one that it's rather curious because it's really similar to the string one. The length command also retrieves the number of items instead of letters in the array. So in this case, we have 5. Also, in the very same way as strings, we can ask whether the array includes a certain item. So if I type in, for example, Jose like so, it returns true. Remember that conversation about the object IDs in between objects and how strings are different in ID? Well, in this case, the include method checks for the value of the object instead of the ID of the object. And that's why this instruction returns true rather than false. The same goes for the numbers, so 2015 also returns true. So it works basically the same way. It's the same mechanism, but for different types. This is actually pretty common in Ruby. A lot of the methods are similar in name, and basically they do the same thing in nature. The same way as we would do the include method, we would use the reverse. Instead of inverting the letters of a string, it inverts the items in order of the array. So my first name would be in the last position. Pretty cool. Now let's check for this empty method with a question mark. Don't forget that. This method really is straightforward, but I wanted to showcase this because if instead of retrieving something like if length equals 0, which does basically the same thing, we actually have a method that's more intuitive. So the empty method exists just to be easier to read. Think of it as syntax sugar. Instead of having to type a long instruction with different tokens, we just use a method. Nothing else. So myArray.empty returns false because we have items in that array. If we were to provide an empty array and call the empty method, this would return true. Let's continue on. Remember how we used the split method to separate the words from my name? Let me just try and do that. If I use the split method here, you will get my name split into an array. Since this is an array, I can use a function inside, and I'm going to use the join method. The join method joins all items in the array into a single string, which is pretty good. Remember though that when trying to join items in an array, it will not consider any token to separate them, unlike the split method. So in this case, if we want to separate these by a blank space, then we need to pass that in. Create a string with a blank space on it, and there you go, that's the result we were expecting. The two methods that I'm going to show you now are a little different in the way that they take a block. A block is kind of a unique concept in Ruby. Basically, it's a chunk of code that is evaluated in the context of a function. Allow me to demonstrate. Let's review our array. As you can see here, I'm going to use the each method. The each method takes a block, and the block can have a list of arguments indicated in between pipes. In this case, the each method takes an item, a variable that represents each different item in that list. So when trying to represent a block, we do it like so. We pass do. If it has any arguments, then we distinguish them in between pipes. So a second argument would be separated by a comma, and so on for the third argument and fourth argument. But in this case, we just have one. Then let's say, for example, we just want to print that item out. So we're just going to type in puts item and finish the block with end, as with any other construct, like if, for, and so on. When I press enter, you will see 3 lines for one method. The each method is called. It takes a block that gets evaluated for each of the items in the list. So pressing enter, you will see that for each different item, it is being printed out to the screen, and we get the array back. Let's do a similar thing, but for another method. I'm going to pick on my array, and I'll type in the map method. The map method is really peculiar. Allow me to create another variable, so inside a block, and for each item in that list, I want to return a different representation of that item. So what if I turn each different item into a string by calling the toS method and then adding, for example, 3 exclamation marks? This will be fun. Let me finish this off by typing the end keyword and notice the result that is going to be expected. We want to have a new array that maps the previous one. So this array will be mapped into a new array of the same length with different items. Think of it as a transformation. So pressing enter, we will get a new array with the same items, but they are transformed. All of those are strings because we called the toS method, and we added 3 question marks to them. So that's pretty cool. I wanted to demonstrate the power of using blocks in arrays and basically any method that requires them. Each and map are just some of them. If you check the link in the description below, you will go to the documentation of the array class, and you will notice that most of those methods take a block. Be sure to pay attention to that. The last method that I wanted to show you about the array is a little different. Let me back up on that array again. Now this time, instead of using dot and the name of the method, I'm going to use this operator. It is a method indeed, but it is represented in a different way. The Ruby language allows this operator to be considered as a method, so we'll go with that. So my array, and then we use the air quote shovel operator, and we're going to shove a new item into that list. So let's add in, for example, tuts plus to the end of the array. Pressing enter, you will see that item right at the end. As a bonus, if you want to create a new item at the beginning of the list, you use the unshift method. The unshift method does the exact opposite as the previous one. Instead of being at the end, it is at the beginning. There you go. Also, one particular thing that you should know about these two is that they are destructive. Because as you can see here, tuts plus was already at the end because we've run this piece of code and it manipulated the array. And because of that, when using the unshift method, we also destroy the array in the way that we have this one at the beginning as well. Checking the contents of my array, the two variables are there. So that's it for the array class. As you can see, the way that these work are the very same thing across the entire set of classes and objects. The usual way of calling methods is by dot, the name of the method, and then arguments, if not a block and everything. Let's jump into the next lesson to go to the next class, the hash. In the previous lesson, we were talking about arrays, lists of different items. This lesson's class is just a little different because it acts as a list but a different kind. It is called the hash, and the main difference between the hash and the array is that the first one has keys. Let me demonstrate by opening the interactive Ruby shell and create one array. So I'll just call the array variable, which will be something like the previous one. So I'll use my name in two different items. And that's about it. Now, let's create a hash. The way we create a hash in Ruby is by using a pair of curly braces. Inside these curly braces, we can pass as many different items as we want. The size that the hash holds really depends on you. Now, as far as the way to define a hash, I'm going to demonstrate how to accomplish it. The usual way is to pass a key and then a value. Let's say, for example, that one key is called first name, like so, and then we pass a hash bracket, as you see here, and then just like this. The value matches the right side of the hash bracket, and the left side is the key. So to this key in the hash, it matches the value of Jose. The same thing we do for example, the last name. I think that's okay. So we use the same hash bracket with another value. If I press enter, you can see that we get our object. In fact, typing hash.class, you will see that obviously it's a hash. As you can see here, I am using strings as keys, but you can pass any basic class that you want. For example, if I switch the last name here for something else, let's say a 3.14, which is a float, it will also work. So basically any type of data can serve as the key in any hash. However, the convention is to use symbols. Allow me to demonstrate. Let's say, for example, that instead of using a string here, I'll use a symbol. Remember the difference between symbols and strings? These are unique in the context of a Ruby program. You don't get to double the amount of space that your Ruby program is taking. And because they are just references to one specific value, it's actually a lot better to use symbols as keys. As you can see, it will work as well. Now, one particular thing about using symbols as the keys in a hash is that there's been an established convention, and actually the Ruby developers have made it so we can use a different notation than this one. Instead of using a symbol and then a hash rocket, you use a last name, for example, and then the colon ahead of the symbol key and match the specific value. The same goes for the other symbol. Replace the hash rocket and the colon before the name of the symbol with something like this. It will work just the same. In fact, if you check this out, it's the exact same notation that's being returned in both tries. So you can know for sure that these are going to be symbols. The convention for the Ruby community is to use hashes with symbols as keys. Let me clear the screen really quick just to clear up all of that mess. Let's create that same hash again. So open a curly brace and then as many keys and values as you want. So the first name will be Jose and the last name will be Mora. There you go. Now, let me demonstrate a few methods that the hash has available in order to manipulate the contents of that hash. The same way as you would do in order to access each item in the array, you can do the same thing with a hash. However, instead of passing an index, you pass a key. If I want to retrieve the first name, I use the symbol that matches the key for the value I want. As you can see, I get Jose. The same would go to the last name in this particular hash, and I will get my last name. If I try to retrieve a value that's not in that hash, for example, the previous 314 that's not there, I will get nil. Remember that. Let's move on. In order to write a particular value, for example, 3.14 equals something. I'm just going to match that to pi, and the hash will be modified in the way that a new entry in that hash will be there. There you go. Our hash is modified in the way that it contains that new pair of key value. Now, the same way as you would do with the arrays, there are some methods that are also shared by name with the same behavior. For example, the length method retrieves the number of items in that hash, the number of key value pairs. We have my first name, my last name, and that new pi key value pair. So that's 3. We can also check whether the hash is empty or not by using the empty question mark method. I will get false because we have those items in that hash. Let me demonstrate by providing an empty hash and calling the empty method there. You will see that it's now true. Since hashes contain keys and values, we can retrieve them separately. If I want to retrieve just the keys from a hash, I use the keys method. There you go. The same will work with the values. So hash.values will retrieve just the values. And notice the object that's being returned by each of the methods. It's an array. You can see here that the pair of square brackets represents array. We can check whether a value is inside that hash or not. If we use hasValue question mark and pass in an argument, the hash will check whether that value is inside or not. If I use pi, for example, it will return true. But pi like this will retrieve false. It is case sensitive, don't forget that. It will check for the equality of the value in between variables. The same way as you do with hasValue, you can use the hasKey method. It checks for the key. If I use first name, because we know for a fact that this key is there, we will get true. The same way, if I pass in a key that's not there, I will get false. So that's pretty straightforward. The last method that I want to show you is really similar to the previous one in the array. It is called each and it takes a block. Remember the blocks? In which we pass in one argument, then there's a body of code that gets interpreted for each different item? Well, the same thing applies to the hash. The way you do this is by providing a key-value pair as arguments to the hash. So I'm going to print out the key first and then the value next. Just so you know what kinds of variables we are facing inside that hash. Finishing this block, you will see that the key goes first and the value goes last. Key, value, key, value. At the end, we will just retrieve the hash. So the particularity of using the each method on a hash is the same as using it on an array, but the variables that go inside as arguments to the block are different. Instead of just one item, we get a key and value pair. Hashes are really important to store information from many different places. You will be amazed at how many hashes there are in many different libraries of Ruby code. It's important that you understand how they work so that you can manipulate them yourself. Besides the standard Ruby library, there is also so much code that's shared by the community. Several other programmers, software engineers like us, have contributed with lots of different projects that seek to assist everyone in the community to do their jobs better. In this lesson, we're going to install one particular gem, and also we're going to run it. This gem is really unique because it's kind of a staple in the Ruby ecosystem. Think of a gem as a library. When you require a certain gem, you will gain access to its code and to its functionality. The gem that we're going to install today is Rake. Even though Rake is part of the standard library, it has been subject to updates. And because of that, we'll need to resort to the gem command to install the latest version. The gem command allows you to do many different things, but the main purpose of it is to install new gems. You type in the install command inside gem and then the name of the gem. We're going to install Rake. Rake is a wonderful utility that allows us to perform some tasks in an easy way. It's kind of a staple in every Ruby project, so be sure to familiarize yourself a little bit with the way that Rake works. So we're going to install Rake through gem install Rake. If you see that you don't have permissions to do so, then go ahead and type in sudo before the gem command. It will prompt you for the password and you should be okay. So I don't need to do it. I'm just going to press enter. Most likely the Rake gem is already installed, but if it were outdated, as you can see here, I did have to update it. So by running this command, I achieved the very latest version of Rake. It is 10.4.2. So now we have access to the Rake gem, which is pretty good. One particular aspect of this gem is that it provides us with the Rake command. You can type that into the command line and it will try to do something. You can see that it launches an error because we have no Rake file. The Rake command assumes a Rake file which contains a series of different tasks. After all, Rake is all around those. So we're going to create our very first Rake file under this folder in particular. You can create the Rake file wherever you want. However, when running the Rake command, you should be in the directory that has that Rake file. So I'm going to create a file under this folder. It is called Rake file. There you go. And now I'm going to the terminal and switch to that particular folder. So cd lessons 5 gems. cd is a command that's available in both Windows, Mac OS X, and Linux systems. So you should be okay. Let me just clear the screen really quick, and typing in the Rake command now, you will see that we get a different message. This time the Rake file is recognized, but the default task is not there. So let's do that. In the Rake file, we're going to create a task. I'm going to point you to the documentation of Rake down in the description below. But just for the sake of the example, we can now type in a task command. This is a Ruby method or function, and I'm going to create the default task. The default task is run when there's no argument in the rake command. So I'm going to do the default task like so, and basically all I'm going to do is I'm going to print out a string. This is the default task. That's all there is to it. This is the task that I want to perform. Of course, that rake is a lot more powerful than this, but this is just so you get to know a little bit about how rake works. Now, if I type rake again, remember with no arguments, I'm going to get this is the default task. Wonderful. Now, we can also create another task. Let's create, for example, a task called hello and create it. This do notation, you most likely recall it from the previous lessons on the standard library. Do end represents a block that's passed in to the task function. In this hello task, we are going to print another string. Let's pass in hello with a particular argument. Which argument should we pass? Well, I'm going to create a name variable here. It is going to be interpolated inside, and I'm going to assign the name variable to something else. The objective we want to achieve is to be able to go to the command line and type in something like rake hello and then an argument. What is the way of rake handling arguments in this specific case? Well, it's a little different from Ruby code, but I'm going to show you how to do it. You use a square bracket and then pass in the argument. I'm going to pass in Bob like so, but I'm going to leave it at this because we still need to finish our code, our task. So, how is it that the task can take arguments? Well, in this specific case, we also open a square bracket to determine an array. In this case, the argument that I want to have is name. In the block, we need to pass in some arguments as well, 2 of them to be exact. The first one is the task itself, and then the list of arguments. With these 2 variables, we are able to go to the arguments and fetch the name argument. We'll just go there, so arguments, and then retrieve the name like so. This is the hash notation to provide the value with the key called name. At the end, we just need to print out the contents of this variable, as you can see on line 7. When we go to the command line, we can use this notation, rake, hello, and then Bob inside square brackets. Hello is the task name, Bob is the argument. Pressing enter, you will see hello Bob. Pretty good. So this is a generic way of using a gem. In this specific scenario, we used rake to do so. We created a rake file, which is a prerequisite of using rake. We navigated to that folder and typed in rake, the name of the task, and if necessary, some arguments. One thing that I want to mention is that you can use a desc function just before each task to provide a description to it. Let me show you why I'm telling you this. If we type in a description such as says hello, and before the first one we should say default task, this will provide a key difference when trying to list all of our tasks. If we type in rake-big T, this is the notation that we need to tell rake in order to list all visible tasks. There you go. Never mind the warning on top. This is just a configuration of mine. Most likely, you shouldn't even have this at all. But you can see that rake default and rake hello name are provided as a means to get us some help. A helper text is provided to us so we can know exactly what tasks we can run. So that's it on installing a gem and using it too. Jump into the next lesson to learn a little bit about testing practices. We're going to install another gem and we're going to use it for testing. I'll see you soon. Up until now, we have been learning how to effectively write some code, create programs, and solve challenges. In this lesson, we're going to write some code that doesn't exactly do stuff, but actually asserts on the code that we normally do. Ruby has a strong testing culture, and there are many tools and packages that you can use in order to do testing. Either one way or the other, you can always find the best suitable tool for the job. In this specific case, I'm going to demonstrate how you can use RSpec. RSpec is a testing framework that is really easy to get started with. I'm going to teach you how to install it and how to bootstrap a project with test-driven development. So we're going to go to our terminal and recall the way to install one particular gem. After all, RSpec is just another library. And as a library in Ruby, we type in gem install and then the name of the gem. Simply enough, we'll type in RSpec like so. So let's press enter really quick, and RSpec will be installed, available in our computer, which we'll then need to require. You can see that the RSpec gem has a lot of different dependencies. These dependencies are actually different mini gems from the RSpec group as well. You can see RSpec support, RSpec mocks, expectations, and the core. At the end, the RSpec gem is just a way of requiring all of the other gems. So once that's done, you will need to type in one specific command. You will type rspec --init. This will bootstrap a simple RSpec helper that will allow us to run our tests. But before we do that, we need to make sure that we're on the right folder. Make sure you're inside the testing folder. Typing pwd, you will see that our folder is exactly that one. From there, I can go ahead and type rspec --init. You will see that two files are created, and also a folder. The first one is a hidden file. It is called .rspec, and if we open that up, you will see some options. The first one enables coloring in our tests, when trying to run the tests, and then we're going to require the spec helper here, which is this file inside the spec folder. When opening this file, you will see a lot of different options, but for now, I don't want you to worry about this. I mean, if you want to read it, then go ahead. It is just a Ruby file, which configures RSpec. There's a lot of different settings that you can meddle with, but for now, this is just a standard, good-looking RSpec configuration. You don't need to do anything as to get started. So I'm going to close all of those. Let me explain to you how testing with RSpec works. You have this spec folder, which will contain all of our tests, or specs. That's why the name of RSpec came along. We are going to write our tests in the form of specifications. Let me demonstrate. I'm going to create a new file here, and I'm actually going to resort to the to-do class that we've implemented in lesson 3.1. So I'll create a to-do _spec.rb. It is very important that you type in _spec at the end of the file name, otherwise the test won't be recognized. As with any Ruby file, you write Ruby code as part of the test. The first thing that we're going to do is require the spec helper. And the reason for that is we need to include the configuration for RSpec in order to run that test. So we type in the require statement and then spec helper. There you go. So we're just basically requiring what's inside the spec helper file. That's all there is to it. The next thing to do is to describe something. We need to test our code against this test suite, so we'll need to describe something. We'll type in the describe method, and after that you can either pass in a string or a class. In this particular case, I'm going to describe the to-do class. As you can see, we are passing a block into this describe method. The next step is to provide as many tests as we find suitable. We type in the it command with a string of text and a block. Inside the block, we'll have our test, and inside the string, we'll have a description of the test we're about to write. In this case, the test that I want to do is, for example, it has a title. So when you come to read this description, you will see that a to-do has a title. Pretty straightforward. So what should we do inside this test, this block of code? Well, we need to simulate as best as we can the conditions to make that test pass. So inside, I'm going to create a new to-do item. I'll call todo.new, and I'm going to pass in a title. Just title like so is okay. Now, what expectation is it that we want to meet? In order to create a valid test, we need to have some sort of expectation or assertion. In RSpec, the way you do that is pass in the expect command, pass in an argument inside, so we need to have todo.title, because that's what we want to assert on, and then we use an expectation. So I'm going to use expect then to equal and then title. This is a good test. We want to have a to-do ready to go, and we are expecting that the result of calling the title method in the to-do object to be equal to the value of title. And that's it. Now, how do we solve this puzzle? After all, this is just a game of cat and mouse. The cat, which is the test, goes after the mouse, which is the actual code. Think of it as a game. You create one cat, and then it goes after the mouse, which we should define later. So if I type in RSpec in the command line, you will see that we have an error. 90% of your time, you will face some errors. And that's okay because the tests will be guiding us to whatever it is we need to do. You can see the exception here. The to-do constant is uninitialized. And how do we achieve that? Well, we need to go ahead and require another file. Of course, you could do something like class to-do inside the test, but that's not exactly the best way to do it. After all, it's a good idea to separate our tests from the actual code. So if we type RSpec again, it would provide us a different expectation, a different error. But we don't want to do it. So we're going to do this in another way. I'm going to require a to-do class just like so. This is going to assume one thing, that we need to have that file ready. So if I press RSpec now, you will see that to-do isn't there. This is a tough one to solve on your own, so I'm going to give you a little help. Inside the main folder, we're going to create a lib folder. There you go, there's the new folder, and inside that folder, we'll create our todo.rb file. In fact, if I go ahead and save it and run the RSpec command once more, the to-do constant is uninitialized. This means that the previous error that we were facing, the fact that we didn't even have a to-do file, that's solved. So we just need to focus on the next one. Let's go to the todo.rb file and type in our to-do class. And this is the way to go. I've saved the file, and I'm going to run the tests again. Notice how this is working out. You can see that all of the tests will be provided as a line throughout the entire cursor. You can see here, of course, that we just have one test, so only one character is being displayed. Next, we have our failures and how we're supposed to handle those. There's the stack trace with the argument error that we need to fix. After all, if we take a look at the todospec.rb file, we are creating a new to-do, but we are passing an argument. This number 1 is the one argument that we're passing, and 0 is the actual implementation of the method. So the method doesn't have any arguments, but we sent one. Going to the to-do file here, we need to define the initialize method, which is the class constructor, and we'll pass in a title. Let's go ahead and just save this like so, and run the tests again. it's important that you take little steps towards your goal. So if you run the rspec command again, the title method is undefined for that specific to-do object. This is pretty good because it means that the previous challenge was tackled. The next step is to actually define that method. Because it is missing, we'll need to implement it. Now, if I run this again, so save the file first, run the rspec command again, and this time we have an expectation error. We expected title to be provided, but we got nil. Nil is that void state, remember? Because we're not doing anything in the title function, it is going to retrieve nil as the last resort. So what we need to do here is to just retrieve the contents of the title instance variable. You might be wondering where we're getting at, but let me just take the little step approach. Let's clear the screen again and run it. We still got nil because the instance variable isn't defined anywhere. The way to fix this is by going to the initialize method and assign that content to the title argument in the method. If we go to our tests now, so let's just run it again, we get a green dot with no failures details, which is pretty good. So let's do one more test just to solidify our knowledge. I'm going to say that the to-do can be marked as done, so I'm going to provide that very text. The to-do can be marked as done. We'll pass a block to it so that we can provide a solid test body. Let's create a to-do again, so to-do.new with some title again. It's okay. Then we're going to mark it as done because this is the behavior that we're expecting to execute. There you go. And now for the expectation. I'm going to expect the to-do status to equal done. Remember, I'm going to separate these so you can learn. I'm going to say that this is the prerequisites, so the preconditions to the test. Then we get the execution, which is the code we are expecting to be executed that is going to modify our state. And finally, the expectation, or assertion, if you will. There are other tools available in Ruby that rely more on assertions rather than expectations. They both mean the same thing, but it's just different terminology. These are the three steps. We have a set of preconditions that need to be met. We execute some behavior to change our state, and then an assertion. In the previous example, the preconditions are the very same thing as the execution, because we just want to create one object and we expect the title to be there, and that's it. Okay, so let's go ahead, save the file, and run the test again. In fact, I'm just going to type in the clear command first so that I don't have to keep, clearing the screen manually. I'll press enter, and you can see this time that the mark as done method is not defined. That's pretty easy to fix. Let's go to our to-do class and implement that method. So mark as done. And this time, let's just take our time and rerun our test suite. Now we don't have the status method. Let's do that as well. I'm going to put that at the top. So status. And if you're smart about this, you will know that this will also fail and retrieve nil. There you go, we expected done, as you can see in the message, but what we really got was a nil value. Okay, now let's do this. Prepare and retrieve the status instance variable, which we're going to manipulate in the mark as done method. Inside, we'll pass in done as the content of the status instance variable, which is going to be retrieved by this method. Going to our terminal once again, you will see two passing tests. We get 2 dots instead of just 1 and a red F. This is a standard testing practice. We create a test suite via the describe method. We pass either a class or a string depending on what we're trying to achieve. And for each different describe block, we provide a series of tests via the it method. The string will describe the general overview of the test. We then pass a block that will have the entire body of the test. So there you go. I hope you understood the basics of testing. This is the basic workflow of doing test-driven development. You write a test, and then you go ahead and implement the code that makes the tests pass. And that's all there is to it, over and over again. Welcome to the final lesson on learning how to program using the Ruby language. I hope you found programming really fun. I remember when I was younger and taking a look at older programmers, friends of mine, and I was immediately fascinated by all of that code with different colors and everything. I thought it was really exciting. And I also hope that you found the same joy that I found in my early days. Magic can really happen before your eyes. If you just persist long enough and find interesting challenges of your own, you will find a lot of reward. Take your time when trying to program your own applications and utility scripts. It's important to find topics that you're really fond of, and I know for a fact that that's the way to learn, by doing things you like and by trying to constantly improve yourself. This is just the beginning of your programming career. I encourage you to persist and to be patient in times of difficulty. I didn't say this was an easy task. It is not. But once you learn and practice and master your craft, you'll be doing wonders in some time. Be sure to check other courses available in our Tuts Plus network. There are loads of different other courses in Ruby and also other programming languages. I encourage you to take a look at them as a way to progress furthermore in your software development adventure. If you have any feedback that you would like to give us, please don't hesitate. You're just starting out, but there's always some help that you could be reaching out to. We're always here to help you if you have any questions or any difficulties. Check our Twitter and say hello to us. If you found this course useful, let us know. If there's something that we could improve to help you, then go ahead and tell us that too. Thank you so much for taking the time in viewing this course. My name is José Mota, and I hope to see you very soon.